Today we're going to perform operations on functions and understand what this new concept of composition is. By the end of this lesson, you should be able to do both. So function notation looks like this. Function notation has that f of x and the g of x, and that is just another way to say y. So don't be confused, it's just another way. They write f of x, they write g of x. They could use anything they want for this f and g just to name it, just to give it the name that it's another function. The x inside the parentheses just tells you what variable is inside the actual equation itself, or the function itself, I'm sorry. So this is asking us to add f of x and g of x together. So all we need to do is just plug those functions in where we see f of x and g of x, and we'd like to use parentheses, although in this case it's not necessary, but we would like to get in the habit of using parentheses. So let's plug in that 4x to the 1/2 power plus negative 9x to the 1/2 power. Now these rational exponents, they work like regular exponents, so we can combine these two together, combine like terms, because x to the 1/2 power is the same as x to the 1/2 power. So 4 and negative 9 is negative 5. So we get negative 5x to the 1/2 power. Now this problem is asking us to subtract. So we do the same thing. We plug in those functions that we have up at the top. So f of x is 4x to the 1/2 power minus negative 9x to the 1/2 power. Now in this case, the parentheses is very important because we have this minus and we have this negative sign in front of the 9. We don't want to forget one of them. Many times we make the mistake of only putting the subtraction and forgetting to put the negative on the 9, and that's going to completely change our problem. So because we're doing 4x to the 1/2 power minus a negative, remember that's the same as adding the opposite, and now we just combine like terms. So 4 plus 9 is 13. So we get 13x to the 1/2 power. Okay, now let's talk about these domains. So remember I told you that a lot of what we do in pre-calculus and calculus has to deal with the domain and ranges of these functions. So this is asking us for the domain of f plus g and the domain of f minus g. Oops, this shouldn't be there. It should be over here. So let's look at what we got for f plus g. So f plus g, and they like to leave out that x to shorten it. I'm not quite sure exactly why, but that means the same thing as what we had before with the f of x plus g of x. It means the same thing. So let's erase that for some more room. So f plus g, we ended up with negative 5x to the 1/2. And then when we did f minus g, we ended up with 13x to the 1/2. Now when we're trying to figure out what the domains of these functions are, we need to tell the person asking us this question, for which values of x does this thing give us an actual answer that we can calculate? That's not imaginary. So in order to do that, we should consider all the possibilities for x that would make this imaginary. So if we look at this, and the 5 and the 13 really have no bearing on the x, that x to the 1/2 power, that means the same thing as the square root of x. Remember that the rational exponents, that means the same thing. So if we're trying to keep these real, then all the values of x that's going to make that not real or imaginary are going to be all the negative numbers. So in this case, the domain is all non-negative numbers. We can plug in 0 because we can take the square root of 0. That's just 0. But anything under 0, negative 1, we can't take the square root of negative 1 unless we include the imaginary numbers. So if we look at over here with the 13x to the 1/2 power, that means, again, 13 times the square root of x. And again, we get the same kind of domain, all the non-negative numbers. Okay, so now this problem, the functions have changed, so make sure we notice that. And it's now asking us to multiply as opposed to add or subtract. So we do the same thing. We plug them in with some parentheses, so 6x and x to the 3/4. And then we use all of our properties that we did the day before and last week to understand that I'm multiplying with the same base. So in that case, I need to add the exponents. Remember, we have an x to the 1st power there. So we end up with 6x to the 1 plus 3/4 When we add that together, we get 6x. 1 plus 3/4 is 1 3/4. And remember, to change a mixed number to an improper fraction, we do 4 times 1 and then add the 3. So 4 times 1 is 4, plus 3 is 7/4. Like so. Or you can think of it as 1 plus 3/4. Well, 1 is the same thing as 4/4, so when I add 3/4 to it, I end up with 7/4. Same thing. Now this one is asking for us to divide. So we plug it in again, 6x on top and x to the 3/4 on the bottom. In this case, I don't really need the parentheses because I'm not adding, subtracting, or multiplying, right? We're just dividing. So remember from yesterday, when we're dividing with the same base, we need to subtract the exponents. So I get 6x, remember there's a 1 on the x on top, 1 minus 3/4. And when I subtract that, I get 6x to the 1/4 power. Remember, 1 minus 3/4, that's the same as 4/4 minus 3/4, which is 1/4. Now here's this problem again where they're asking us to find the domain. So let's go back where we got f of x times g of x. That's 6x to the 7/4 power. And then dividing, that was 6x to the 1/4 power. So of course we're going to look at these x's and figure out what numbers we cannot plug in for x. So for x, the root this time is the 4th root. So when we think about all the numbers that we can't plug in for x, again, we cannot use negative numbers because the 4th root is, if you take the 4th root of something, you can't get a negative number. So most definitely non-negative numbers. Here's where the tricky part comes in. When we look at this division, f of x was 6x. And x to the 3/4 power was in the denominator. So even before I simplified it, I've got this x to the 3/4 power on the bottom. And the one number that we cannot have in the denominator is 0. Remember, that's going to give us an undefined number. So not only for this problem can they not be negative, but they also can't be 0. So in this case, we can easily write this as x is greater than 0. And technically, we can write the non-negatives as x is less than, or I'm sorry, not less than. We could write that as x is greater than or equal to 0, because it could be 0 or anything above 0. Either way is completely fine. Now composition. Composition is when we're going to put one equation into the other one wherever we see an x. So let's see how that happens. So in this case, we want to put the g of x inside the f of x. And we want to put that everywhere where we see x, because look, this is like this, right? We want to plug this in for all the x's. So we take f of x, we take out the x, and we plug in g of x. So we get 5x minus 2. And we simplify. So we have a negative exponent here, so this whole thing needs to go in the denominator now. So we end up with 4 over 5x minus 2. And I can't simplify it any further, so we're going to leave it like that. Now you pause the video and try this one. Okay, so this composition, we want to take f of x and plug that into g of x this time. So we take g of x, we take out the x, and we plug in f of x. And then we simplify. Well, that's just multiplication, so 5 times 4 is 20, and then x to the negative 1 minus 2. And then we have a negative exponent here, so that needs to go in the denominator. So we end up with 20 over x minus 2. Now in later chapters, we'll find a common denominator and combine them together. So for now, you can leave it like that. Okay, so pause the video and try this one on your own. Now this one's a little tricky. We're taking f of x and plugging it into f of x. So let's take f of x and plug it into f of x. So we remove the x and we plug in f of x, which is completely fine. We're allowed to do that. So now we have to simplify it. So when I simplify it now, This is a power to a power, so I can distribute the -1. So I get 4, and then 4 -1, and then x to the +1. And I cannot multiply these together, remember, because they don't have the same exponent. So I have a negative on the 4, so that moves down to the bottom. So I get 4 over 4x. And now I can cancel the 4's because one is on the top and one is on the bottom, and I end up with 1 over x. So now let's talk about those domains. So if we talk about g of f of x, that was 20 over x minus 2, and f of g of x is 4 over 5x minus 2. So again, we look at the x's. This x can be any number we want, positive or negative, because we're not taking any roots this time, except for 0. So we can say all real numbers except 0. And on the second one, the f of g of x, we're only concerned about this part right here. That thing cannot be 0. So if that thing is 0, then we can solve for the denominator and figure out when it is 0 and make sure that x can never be that. So we add 2 to both sides and then divide by 5. So x in no way can equal 2/5, because if I plug 2/5 in for x here, I get 0, and I can't have 0 in my denominator. So in this case, we have all reals except for that 2/5. Now this one's going to get a little bit complicated because we have fractions within a fraction. So in case you can't read that, f of x is 3 over x plus 1. So we take g of x, and we take out the x and plug in this thing right here. So 3 over x plus 1 plus 5 all over 2. And for now, because I have not taught you rational expressions yet, we'll talk about that in Chapter 8. We're just going to leave it like that. So now we're going to evaluate these compositions of functions. So there's two ways we can do it. We can actually do the composition and figure out what function we get after that. Or what this says is I need to take that 5 and plug it in everywhere that I see an x and f of x. So let's do that. I end up with 15 minus 8, which is 7. That is what f of 5 is. So now I can take that, because I need that here, and plug that in for x again in f of x. So I take that 3 and 7 minus 8, so that's 21 minus 8, and I end up with 13. So if we're trying to evaluate these functions, all we have to do is plug it into the first one, which is the f, and then once we get that, plug it into the second one, which is, again, in this case, f. So here are some practice problems. There are some tricky problems in the middle. You don't have to worry so much about those rational expressions when we plug in the problem and we end up with some really complex, weird fraction like that one that we had before. I just want to see that you understand how to plug it in, where to plug it in, and then we'll talk about simplifying that when we get to Chapter 8.